So you want to be a DevOps engineer, right? But when you start looking into it, the path can feel, well, super overwhelming. There are so many tools, so many concepts. In this explainer, we're going to cut through all that noise. We're taking the best expert guides and community roadmaps and boiling them down into a clear, step-by-step journey. You'll know exactly where to start and what to learn next. Let's get into it. First things first, why is this role so incredibly important right now? I mean, the tech world is just exploding. You've got AI changing, well, everything. You have companies juggling multiple cloud environments, and there's this constant pressure to get new features out faster and more securely. DevOps is the glue that holds all of this together. It's the engine that makes modern tech work, and that's exactly why it's one of the hottest jobs out there today. Now, I know when you look at a typical roadmap, it can feel like this massive, intimidating checklist. But I want you to think about it a different way. It's not a list, it's a series of layers. You build one solid layer of knowledge, and then you build the next one right on top of it. And it all starts with a rock-solid, non-negotiable foundation. So let's dive into layer one, the foundation. Seriously, these skills are everything. If you get these right, every other layer we add on top is going to be stable and strong. If you skip this, things get real shaky real fast. And this foundation, it's really built on three core pillars. First, the operating system that basically runs the internet, Linux. Second, understanding how computers actually talk to each other, networking. And third, the system that keeps track of all our code and configurations, Git. Let's kick things off with Linux. It is the absolute backbone. Almost every cloud server, every DevOps tool you're going to touch runs on Linux. So you've got to get comfortable on the command line, the CLI. That means knowing your way around with commands like ls to see files, cp to copy them, using ps to see what's actually running on a server, and cmod to lock down permissions. This is your day-to-day for managing servers. Okay, next up is networking. Now, you don't have to be a networking guru, but you absolutely need to know how data gets from point A to point B. Concepts like the OSI model, and don't let the name scare you, it's just a way to understand the different layers of communication, are key. And you for sure need to get how DNS and IP addresses work, because that's how everything finds everything else online. Without this, trying to figure out why your app can't talk to its database is, well, it's a nightmare. And the third pillar is Git. Now, you might think of Git as just for developers, right? For application code. In the world of DevOps, it is so much more than that. It becomes the single source of truth for everything. Your infrastructure, your automation pipelines, all of it. It brings this incredible discipline of version control and collaboration to your entire system, not just the code. And this quote from the community just nails it. It really boils down to this: no Git, no DevOps automation, period. Every single automated thing we do, whether it's building code or deploying a server, it all kicks off with a Git commit. If your Git game isn't strong, your automation will never be reliable. All right, with that foundation in place, we're ready for layer two, powering the automation engine. This is really the heart and soul of DevOps. The whole goal is to automate as much as possible to reduce human error and, let's be honest, save ourselves a ton of time. To automate, you need a scripting language. And while you can do some simple stuff with shell scripts, when you need more power, the community overwhelmingly points to one language, Python. It's just so readable, and the libraries available are incredibly powerful. It's the perfect tool for writing scripts that can handle anything from simple backups to really complex deployment jobs. And here is the perfect example of where that automation shines, the CI/CD pipeline. It stands for continuous integration and continuous deployment. So check this out. A developer pushes code to Git, see, there's our foundation, and that simple push automatically kicks off a process. A server grabs the code, builds it, and runs a bunch of automated tests. If everything looks good, it's automatically deployed. That's the automation engine in action. Beautiful, right? Okay, our foundation is built, the automation engine is humming. Now we get to the really fun stuff, layer 3, which is all about mastering the modern tech stack. The way we build software has completely changed, and it all started with a huge shift in how we think about architecture. So in the old days, we built what are called monoliths. Just picture one giant single application where everything, the user login, the payment system, the front end, it's all tangled together in one big lump of code. The problem? If you needed to change one tiny little thing, you had to rebuild and redeploy the entire application. It was slow, it was risky, and frankly, it was a huge pain. So that brings us to the new way, microservices. The idea here is brilliant. We break that huge application into a bunch of small, independent services. Now the payment team can update their service and deploy it all by themselves without ever touching the user's service. It's amazing for speed and autonomy. But it creates a new problem. How on earth do you manage hundreds of these little services all running at once? Well, the first part of the answer is containerization, and the king of containers is Docker. A container is like a standardized shipping box for your microservice. It packages up the code and all of its dependencies, everything it needs to run, into one neat little unit. This finally solves that age-old problem of a developer saying, "But it works on my machine." With Docker, if it works in one container, it works in all of them. Okay, but what happens when you don't have one container? You have hundreds or even thousands. You can't manage that manually. No way. And that is where container orchestration comes in, and specifically Kubernetes. Think of Kubernetes as the master controller for all your containers. It handles deploying them, scaling them up when you get a lot of traffic, and even restarting them if they crash. It's basically the operating system for the entire cloud. All right, we're making great progress. We've got the stack down. Layer 4 is all about adding that professional polish. These are the skills that really separate a junior person from a senior engineer. This is how you build and maintain systems that are truly production-ready and reliable. In modern DevOps, we don't click around in a web console to create servers anymore. We use code. There are two key approaches here. First is infrastructure as code, with a tool like Terraform. Then there's configuration management, with a tool like Ansible. The best way to think about it is this. Terraform builds the empty house. It creates the servers, the networks, the firewall rules. Then Ansible comes in to furnish the house. It installs the web server, configures the database, and gets all the software running correctly inside. You know, having a system running is one thing, but if you can't see what's happening inside it, you're just flying blind. That's where observability comes in. We need monitoring with tools like Prometheus to watch things like CPU usage to know if a server is about to fall over. We need logging with something like the ELK stack so we can search through all our logs when something goes wrong. And of course, security is absolutely critical. We're talking about everything from managing passwords and API keys safely to using security features built right into Git. And that brings us to our final and maybe most important layer, the Launchpad. We've talked about a lot of concepts and a lot of tools, but none of that knowledge means anything if you don't put it into action. This layer is all about getting your hands dirty. You know, I've talked to so many experienced DevOps engineers, and I always ask them for their single best piece of advice. The answer is always the same. You can read books and watch videos all day, but the only way you will truly learn DevOps is by doing. You have to build things, you have to break things, and then you have to figure out how to fix them. So to get you started, here are 3 simple, totally beginner-friendly projects that you could literally start today. Try writing a GitHub Actions workflow that automatically deploys a simple website. Or take a little app and write a Docker file for it. Or even just go to a cloud provider like AWS, create a basic virtual server, and learn how to connect to it securely. These small wins are what build real skills and momentum. So there it is. We've laid out the entire roadmap, layer by layer, from that crucial foundation all the way to the professional polish. The path is clear. The only question left is, what are you going to build first?